In this video, we're going to talk about Pythagorean Theorem notes. We start with given two sides of a right triangle, and we're going to find the third side using what's called Pythagorean Theorem. Pythagorean Theorem is a squared plus b squared equals c squared, where c is called the hypotenuse, and a and b are called the legs. Legs are the sides that form the right angle. Remember that a right angle is 90 degrees. It's a 90-degree angle. That means that the legs are perpendicular to each other. The legs are the sides that are going to be touching the right angle. The hypotenuse then is the side that's across from the right angle. And the hypotenuse is the longest side of the right triangle. So let's take a look at this triangle. In order to do Pythagorean theorem, you have to know two sides to find the third side. You're going to be given two legs, find the hypotenuse, or an hypotenuse and a leg, find another leg. Has to be on a right triangle. The Pythagorean theorem only works on a right triangle. It says that if you take the a squared, the leg side squared, plus the b squared, the other leg side squared, those two together should equal the c side, the hypotenuse side squared. Again, only works on a right triangle. Remember, right triangles has a 90-degree angle. We also know that the legs are the sides that are touching the right angle. The hypotenuse is the side across from the right. Now, because there is only 180 degrees in a triangle, if you add up the angles of a triangle, there will be a total of 180 degrees. If you take 180 minus the 90, then you see that these two together have to be a 90 in total. That means that the largest angle possible is the right angle. Because it's the largest angle, across from the largest angle is always the largest side. That's why the hypotenuse is always the longest side of a right triangle. Now we can use the a squared plus b squared equals c squared, the Pythagorean theorem, to solve any problem where I'm given two sides and need to find a third side. Either like number 1 or like number 2, where I have two sides and given a third side. These are really the only two types of problems you're going to have in this entire unit. All you're going to have to do is figure out, does it look like number 1 or does it look like number 2? That's it. That's all we're going to do this unit. Just some version of one of these two problems. So remember, we use Pythagorean theorem when you're given two sides of a right triangle and you want to find the third side. Let's start by looking at number 1. In this problem, the x is the side across from the right angle, so that's the hypotenuse. So this means that the c is our x, a is the 3, and b is the 4. Now the legs don't matter which one you call it, so I called a 3 and b 4, but I could flip them around, and I could call a the 4 and b the 3. It doesn't really matter which one is the legs, however you label them. What does matter is what's the hypotenuse. The hypotenuse is the important one. So labeling our triangle, we have leg in blue is a equal to 3, leg in green is b equal to 4, and the hypotenuse in red is our x. We can now plug that into our a squared plus b squared equals c squared, our Pythagorean theorem, substitute in those values, and we get 3 squared plus 4 squared equals x squared. 3 squared is 9, plus 4 squared is 16, equals x squared. Remember, 3 squared means 3 times 3. The squared is how many times you're multiplying that number. So 3 times 3 is 9. 4 squared means 4 times 4, which is 16. That's what 4 squared means. We followed our order of operations by doing our exponents first. Now we just have 9 plus 16. We can add those to get 25 equal to x squared. And now trying to get x by itself, what's the opposite of squaring? Well, that would be square rooting. So we have the square root of 25 is equal to the square root of x squared. Square root of x squared is just x equals. And when we take the square root of 25 of x squared, we have both the positive and the negative 5. Now the square root of 25 is just 5, but because we're solving this x squared problem, there's actually two answers you can put in for x that when you square it, right, two numbers you can put in for x, when you square it, that equal 25. 5 squared is 25, and negative 5 inside parentheses, anytime you substitute in for a letter, it's inside parentheses, negative 5 also works. So when you're solving equations with squares, you have to consider both the positive and the negative, as both of those are mathematical answers. These are both mathematical answers. 5 and negative 5 both work in this equation. However, because this is a side length, length cannot be negative. So our only answer is x equals 5. This answer should make sense. Remember, the hypotenuse has to be the longest side. 5 is indeed bigger than 3 and 4. We can check that this is correct by plugging in. 3 squared plus 4 squared should equal 5 squared. 5 squared is indeed 25. We already showed that the left side is 25, so this is our answer. Now let's take a look at number 2. Let's try to use the same logic that we did on number 1, but you'll notice that it's slightly different. The x is not in the same spot. It is not across from the 90-degree angle. It is actually next to that. Remember, is that the hypotenuse or leg? Why don't you take a moment, try to fill in this information before you continue on. Otherwise, that's going to look like this. We see that the hypotenuse is the side across from the 90-degree angle. In this case, that's the 5. So C is 5, A is 3, and B is our x. And again, it's okay if you switch your A and B around. If you called A your x and B your 3, that's be okay. What is important and you cannot change is the C here is the 5. It's the side across from the 90 degree. That's called the hypotenuse. The other two then don't really matter which one you call them, as long as you know which one is the hypotenuse. So 3 is A, B is x, C is 5. Why don't you take a moment and plug that into our a squared plus b squared equals c squared Pythagorean Theorem formula and see which of you can solve that. Otherwise, that looks like this. We get 3 squared plus x squared equals 5 squared. We can do our squares, so 3 squared is 9 plus x squared equals 25. So remember, the goal here is when you are trying to get the x by itself. We have 9 plus x squared equals 25. I'm trying to get the x squared by itself. So what should I do with this positive 9? We subtract both sides by 9. This gives us x squared equals 16. Now we need to get x by itself. How do I undo squares? We take the square root and we square root both sides. Remember, this technically gives us both x equals positive and negative 4. However, like we said, length cannot be negative. Thus, our only answer is x equals 4. Now, moving forward, you can skip doing the negative length. However, there are other cases where you're going to need the negative number. So just be aware, when you take the square root of x squared and doing that with a number, it's both a positive and a negative. There's other contexts where you need to have that negative. So just remember that's part of it. On all these Pythagorean problems, though, because length is positive, we're only going to take the positive answer. We got 4. That should be a reasonable answer. Remember, the leg should be smaller than the hypotenuse. Hypotenuse is the side across. Notice number 1 and number 2 are actually the same triangle. 3, 4, 5. 3, 4, 5. Just depends on which part they are given and which part you're trying to find. In number 1, we were trying to find the hypotenuse. We were given the 2 legs. On number 2, we were given a leg and a hypotenuse, trying to find a leg. So let's extend this Pythagorean theorem in general. If you want to find the hypotenuse, remember you're looking for c squared equals a squared plus b squared. My goal is to get c by itself. If I want to solve for c here, all I need to do is take the square root on both sides, and that was c. So notice in general then, c is equal to the square root of the a squared plus the b squared. Or more generally, if I use HYP for hypotenuse, the hypotenuse is simply the square root of our a squared, a is a leg, squared, plus b squared, b is another leg, so that's a leg squared. So it's a square root of the leg squared plus the other leg squared. Your two legs are each squared, and then you add them together, and then you take the square root. That's how you find the hypotenuse. Now what happens if I'm trying to find the leg? Let's say the leg I'm trying to find is A. Could be B, it doesn't matter, but we'll say it's A. If I'm trying to find A, I first have to get A squared by itself, so opposite of plus B squared is minus B squared. This gives me A squared equals C squared minus B squared. Again, to get rid of the square on the A, I take the square root, so A is equal to the square root of C squared minus B squared. Or more generally, again, if I use HYP as my hypotenuse, that's the abbreviation, C, is that the leg or the hypotenuse? C is the hypotenuse, which is squared. But this time, because I am subtracting, because I had to subtract, I'm going to minus my leg squared. So the leg is simply the square root of your hypotenuse squared minus your leg squared. Remember, just always have the bigger number first. So here's our general hypotenuse. Here's our general way to find the leg. I suggest that you write this work using the square root. I always immediately just write the A equals square root. Typical mistake that students make is forgetting to do the square root at the end. However, you can solve A, B, and C just like we did in the previous two examples. It doesn't matter, either way is fine. I just think this is a better way to ensure that we have the correct answer. At this point, what do you notice about the finding the hypotenuse or finding the legs in general? Notice that for both finding the hypotenuse and finding the leg, you're taking the squares of each number, right? So you know two numbers, you're going to square both numbers, you're going to square the numbers. Again, if you write the bigger number first, no matter what was the bigger number first? You're squaring, you're squaring, you're squaring, you're squaring. The only difference is whether you're going to add or subtract. This one I added, this one I subtract. That's it. So the question is, do we add or do we subtract? How do we know? Well, when we're finding the hypotenuse, since the hypotenuse is the largest side, we want the answer to be what? Bigger or smaller? Bigger. And because we want our answer to be bigger, should we add or subtract? Add. If we want the largest side, that means it has to be the biggest number. That means you're going to add, not subtract. Now, using similar logic, when we're finding a leg, since the leg has to be smaller than the hypotenuse, we want the answer to be smaller, of course. Therefore, are we going to add or subtract to make our answer smaller? Subtract. So very simply, whatever the numbers that you know, you're going to square them, right? Whether hypotenuse or leg or leg. You're going to square it, you're going to square it, you're going to square it, you're going to square it. We're going to take the square root of the whole answer. The only thing you have to decide is are you going to add them first or you're going to subtract them first. If you're trying to find the hypotenuse, you want it to be bigger, largest side, so you need to add. Right, hypotenuse, we're going to add. If we're trying to find the leg, since the leg has to be smaller answer than the hypotenuse, we're going to subtract. That's it. That's all we have to do. So let's apply what we just talked about to examples 1 and 2. Again, we can solve them just like we did before, doing the A squared, B squared equals C squared, plug in the values, and just solve. Or we can use these shortcuts. Since we're going to take the square root, we're going to have the two numbers squared. We're just deciding we're going to add or subtract. So let's look at example 1 again. Find the value of x. See if you can do what we did. Otherwise, that's going to look like this. We already see C is the x, right? That's the hypotenuse. We see that the 3 and the 4 are the side next to the right angle, so those are the legs. Since x is the hypotenuse, that's what I'm trying to find. I'm trying to find the hypotenuse. So our answer has to be bigger or smaller than 4. We see it has to be bigger than 4, right? This is the leg, so the hypotenuse has to be bigger. Therefore, what are we going to do? We're going to subtract or we're going to add? We're going to add. We're going to add the squares together and take the square root. So hypotenuse is simply the square root of the leg squared plus the other leg squared. One of the legs is 4, so that's 4 squared. The other leg is 3, that's 3 squared. Again, what are we doing? Add or subtracting or adding? So this is where I would just jump right into typing this in the calculator. X is equal to, just simply type in the square root on the calculator, then do the 4 squared plus 3 squared, all that's underneath the square root. you could simply type that in, jump to the answer. Otherwise, if you want to break it down, 4 squared is 16. We're still adding. 3 squared is 9. 16 plus 9 is 25. The square root of 25, x equals 5. Again, the square root of 4 squared plus 3 squared, all that's underneath the square root. At this point, that would be considered work. You could type that in the calculator and jump to the answer. Number 2 then, very similar. We're going to again find the x. First thing we're going to do is find the hypotenuse. We see the side across from the right angle is the 5. That makes 5 the hypotenuse. 3 is a leg, and x is a leg. So we're trying to find the leg. So again, C is 5, A is 3, B is our x, so that's what we're trying to find. We're finding a leg. So should our answer be bigger or smaller than 5? Should be smaller since it's a leg. We know the hypotenuse is 5. Therefore, we're going to add or subtract. Subtract. We're going to subtract the squares and then take the square root. So we have our leg is simply the square root. Our hypotenuse squared minus our leg squared. Our hypotenuse is what number? It is 5. Our leg is what number? That's 3. And we are going to subtract them. So in number 2, x is equal to the square root of 5 squared minus 3 squared. Again, at this point, you could jump right into the calculator. Just type that in exactly like it says with your 5 squared minus 3 squared all underneath the square root. Otherwise, 5 squared is 25. We're subtracting the 9. 25 minus 9 is 16, so the square root of 16 is 4. Notice all I did was I wrote the bigger number first, and then squared each number. The only difference is, am I adding or subtracting? Do I write the bigger number first, then you're just adding or subtracting. Don't forget to do the square root. Either do it right away like this, type it all in, or do it at the end, doesn't matter. Remember, should your answer be bigger or smaller than the hypotenuse, or bigger and smaller than the leg? If you know that answer, you know you need to add or subtract. This is all you're going to do. Either like number 1 or like number 2. Everything's some version of that in this unit. And that's Pythagorean Theorem in a nutshell. If you have a right triangle, you can use that to find the side lengths. One last, the converse of Pythagorean Theorem simply says if a squared plus b squared equals c squared, then you have a right triangle. So to use Pythagorean Theorem, we have to have a right triangle. When that's true, then you can use your 2 sides to find your third side, because you know that relationship is always true in any right triangle. The converse of Pythagorean Theorem simply says if a squared plus b squared does equal c squared, if you have 3 sides and you test those 3 sides with the longest side being your c, and left side does equal the right side, then you can verify that you do have a right triangle. That's simply the converse of Pythagorean Theorem. So if I give you 3 sides, you can test those 3 sides and see if the 2 smaller sides squared added together is equal to the third side squared, then you know it, you actually have a right triangle.